So yeah, scaling, exporting, monitoring resources. I apologize for the title. I threw this around the office to try and get some ideas, like catchy ideas and things like that. I think they sabotaged me. Regardless, I'm Christian, I'm from Anchor. We're a managed hosting provider. I'm just going to talk about sort of our evolution as to how we implemented Storeconfigs and exported resources to automatically configure our monitoring system, as well as what we're doing before that, sort of the problems we faced, and then the issues we had once we got this into production and started trying to scale. So yeah, where do we come from? Grueling manual deployments. So I'll go into that. Gaining some maturity, using Storeconfigs for great justice. Making it bigger, we needed to make it work at scale and with lots and lots of hosts. So the olden days, process. So as I said, we're a managed hosting company. It means we get server builds, customer wants a new VPS or a new dedicated machine, something like that. Something comes in. The problem that Anchor has specifically is that there's no standard build. So every customer is a snowflake, and they all have unique requirements. Now, the old process was such that there was a little manual checklist on the wiki. Sysadmin would come in, have to provision something. So they get the order, build the server, install the OS, do all the silly stuff that these days we wouldn't really even think of doing manually. And then we'd add services to Puppet. So by doing this, we'd use Puppet to automatically install the services on the machine, but we would still have a manual process such that the admin would have to go in and say, this machine has Nginx, this machine has MySQL, whatever else. And then we configure monitoring. This was a separate process. This wasn't done in line with the actual service configuration. So after the machine was built in production, the sysadmin would then have to go, okay, I now have to go and monitor all the services on the machine. Go on back, audit the requirements, see what they were doing, make sure that they go and do the config. And monitoring is kind of important. The service goes down and the customer's contracted us to keep it online. It's generally not a great thing if we're not actually monitoring it in the first place. So just a slightly confusing slide of what we used to do. So there were two processes, as I stated, and they weren't really correlated or connected in any particular way. We've got the server build process down the bottom. We were using revision control for quite a while. That serves us well. But the issue we have with this is that both of these processes work in isolation, so there's no connection between the two. After they got through the server build process, then go back to the configure monitoring. So they'd have to check out the repo, prob the configuration based on the customer spec, commit, push, and then deploy that to the Nagios machine. And as I said, we may or may not have missed something. That's, this is going to work great. Is there any way to turn off these lights here?
Yeah.
Awesome. Okay, because all of my examples are in that color. This is sort of an example monitoring spec. There's a crazy macros here, but it's very much a manual process. So the admin would have to come in, write up all the stuff they wanted, or go and copy and paste from another config that looks similar, and remember to add all the services. Wasn't really a great process. There were quality assurance processes, auditing processes in place, such that someone else would have to come along and verify the build afterwards. And look, this is kind of the stuff we were trying to achieve. Lots of services, lots of green lights, they're great. Nagios gives you green, looks awesome. Unfortunately, what we ended up with a lot of the time is that if you had a lot of green services and a lot of services there, someone would come along and QA their machine, they may or may not do a great job. They'd see lots of green lights, lots of services on the machine and think, hey, someone's done the right thing here, and it may not necessarily be the case. In this instance, I've forgotten to monitor Nginx and a couple of websites. It's generally not the greatest thing in the world. So, evaluation. What did it do for us? Well, it worked. Assuming someone does the right thing, this was working for us. We got all the services in, we were monitoring them, we were delivering, to our SLAs, and stuff worked. It's fairly easy to set up. Now, some of you who've used Nagios and dealt with all the primitive types may not agree, but at its base, it's not too complicated. Go in, define services, check commands, apply them to hosts. So yeah, fairly easy to understand, and finally, easy to manipulate. So say we came down the track, wanted to add a service, it's pretty easy to go and just add another command or another macro to a particular machine. One line, commit, push, done. What didn't work? Well, as I said, it's inconsistent. one machine may look different to another, or it may be monitoring 10 services of one variety on one machine and 7 of another on a very similar one, when in fact we want a standard config across all of them. The other problem would be that an admin might come in and to say, all right, I need to define a new check or a new command, and not realize that an admin had done that 3 weeks ago and not find the config. So someone might write a different check for the exact same thing. There's no consistency there. And that meant that if someone went in and wanted to update a check and make it do something different or return some different data, obviously only one of them would get done. And the obvious one, it's easy to make mistakes. So how do we fix it? Well, as I said, it's a very manual process, and we're sysadmins. Let's take the humans out of the equation. So first, obviously, don't let the human configure the monitoring. We've got tools for this. We've got Puppet, we've got a lot of other internal automations, we've got scripts. And ideally, we don't want to add any more tools, so we want to use our existing tool chain, our existing data. The second thing is don't let the humans build the machine. So we've actually got another couple of projects that I recommend you check out. One's called Make Magic, the other's Mud Puppy. So we use these internal automation tools to actually provision our machines from the sales process through to completion. So a salesperson, signs up a new customer says, I want all these specific things. The salesperson waves their hands in the air, and these things convert that into a working machine that's online with the Puppet manifest and handed over to the customer with very little intervention on our part, which is great. But we still have the issue of, the monitoring was an external process. So that was the thing we had to fix. So what are our goals? We want a standard base monitoring configuration to be enforced. So I want, some standard minimal level of monitoring across every single host I provision, and I need that to be consistent. Secondly, monitoring should be derived from the service configuration. So it reduces the chance that a service and its monitoring can become out of sync. If I add a service, I definitely want the monitoring to be added automatically in some fashion. Next, the monitoring should be defined in the same place as the service. So I don't want 2 repositories for this, obviously. I don't want to keep my monitoring configuration in one repo, my Puppet config in another repo, or my service configuration of some respect. Moving on, the monitoring configuration should hide the implementation details. So there should simply be an interface to say, this is monitored. I need to have a standard interface such that I can go into the background and change the way the check works, make sure everyone's still using that same interface without actually changing, how the check works, how they're using it, anything like that. I need to go and change the monitoring. Say I want to add some, new service data. Say I want to now log MySQL connection status or something like that within my MySQL check. I can go and add that in the background without all the consumers of that monitoring having to actually change anything. Minimal redundancy. So I don't want to be defining checks all over the place. I want to be defining checks once. That's a pretty obvious thing. It's a standard coding paradigm. And be flexible. So Postgres might be running on a different port on that machine. I don't want my monitoring to lock me in and say, you have to use port 80 for every single web server. I want to be able to go and change that as I require. I don't want to lock people in. So I spoke about using the tools we have. Obviously, we're going to try and use Puppet for this because it's new and shiny and cool. So bonus for that is in use. It already knows about our services. So our business rules actually dictate that any time we try to add a service to a machine, it has to go through configuration management. There's no people going in and manually logging onto boxes and saying, apt-get install. It doesn't happen. It has to go through Puppet. So we've already got that win. It's capable of generating Nagios configuration out of the box. So there are a lot of native types that use Naginator to go and do crazy generating things. As we'll get to, Storeconfigs are obviously a big win. Finally, robots are consistent. So if I'm doing this automatically, I know that it's going to be done the same way every time, and they're reliably consistent. So I know that it is actually going to get done. So I spoke about store configuration. I'll give you just a brief rundown for those who haven't seen it before. And before I start, I'll say that this does not represent the data model that Storeconfigs use in any way. It's just a logical, an objective explanation. But essentially, say I've commissioned 2 hosts. I've got Bob and Alice. Bob has his own subset of services, so you can see there he's got Nginx, Redis, Postgres. Alice has Apache and MySQL. Out of the box, I can then go and say, export specific resources. So I can say, from Alice's configuration, I can advertise that Alice has Apache and MySQL. This gets sent to the Puppet Master in what's known as an exported resource. Puppet Master then persists this data to the Storeconfigs database. And then finally later, my Nagios machine can then be configured to go along, sweep up all the store configuration that's associated with Alice and Bob that pertains to monitoring, and then go and configure itself and say, all right, I've got checks set up. Alice has Apache MySQL, Bob has these other services, and go and automatically configure the monitoring, set it up, reload Nagios, and start pinging those machines or whatever the checks happen to do. At its base, it's pretty simple to set up off the bat, and it works pretty reliably. So look, this is actually, I tried to come up with some simple explanations, but the Pro Puppet book has some pretty basic ones. This isn't how we're using it, but if you wanted to do this yourself and set up basic service check, this is the sort of thing you'd start off with. You'd have this class, you'd include it in your node. So you'll see there's two exported resources. That's what the double @ symbol means. The first defines the Nagios host. So that's simply to say that this is a host that has to go into Nagios. The second is a service, so it's actually saying, this is a check that you need to run against this host. Now, these types don't actually get realized in any fashion on the actual host. They're simply data that gets exported from the host when Puppet runs. So the host itself, whilst it includes this class, doesn't actually do anything. It's simply sending data back to the Puppet Master to say, hey, I've got these services, or you need to do something with this information later. You then go include something like this on your Nagios machine. So it's very basic. Install Nagios, make sure it's on, and you'll see the spaceship operators here. So what they do, they go along and collect all of those resources. Simply say, all right, I want to collect all the Nagios host resources and all the Nagios service resources, and then realize them. So it actually then goes, then goes and instantiates these, and says, all right, I've got to actually set up a Nagios host for Bob and Alice. I've got to set up a Nagios service for Bob and Alice, and Bob's your uncle. We have automated Nagios configuration based on our host configuration, which is great. So what did this give us? That. And it was awesome. We got it every time. We got services configured, host set up, checks configured. Awesome. So we went through and we tried to evaluate this solution and say, all right, what's it doing for us? So it works reliably, as I said. We don't miss anything. So we actually tie all of our exported resources and checks back to the services themselves. So say I go and include my MySQL module, it automatically exports a resource that says, hey, go and monitor MySQL on this host. The Nagios machine then comes along later and says, okay, cool, I've got to actually pick up this configuration and then go and do something with it. Defines a check, sets it up, starts running it. Awesome. We achieved all the goals that I spoke about before, which was again another big win. And we used our existing toolchain to do it, so we didn't have to introduce any further complexity besides the crazy Storeconfig setup. So what didn't work for us? Puppet runs on the Nagios server were taking forever, and it's kind of where the focus of this talk heads towards. So if any of you caught Deepak's talk yesterday, because he went to talk about Puppet DB and the problems he's trying to solve with scaling, and it looks really awesome. I'll say up front that we haven't tried this yet, but I recommend everyone does. But look, actually persisting all this data, sending it into a centralized repository, so there's a lot of load on your actual Storeconfigs database. And we found that actually on a Nagios machine, when we went through and tried to run Puppet, it would take forever. And we saw a linear relationship with the actual runs, the amount of exported resources we have versus how long the Puppet run would actually take to execute. So we're exporting many monitoring resources, and the actual Nagios machine was obviously having to go do something with them all, set up checks, define monitoring, and it was taking a long time. So we obviously had concerns over whether this was going to scale for us, whether this was going to, solve all of our problems in the long term. So as I said, the individual node times were acceptable. Run times on a Nagios machine were unacceptable. We obviously came to the very quick conclusion this wasn't going to work as we added lots and lots more hosts. So there are some basic recommendations. I'm not going to go into all of these. They're very well documented. If you've got the Pro Puppet book, they're all in there. They're actually all on the Puppet website as well. I'm not going to go into how to implement these in detail, but they're things that you should be doing if you're not and you are using exported resources right now. So as I said, disclosure, I haven't used PuppetDB. We're still running on 2.6 actually, so you need 2.7 for this, or crazy new versions of Enterprise. As I said though, I'm really keen to try it out and see if it solves my problems. I'm not sure if it will solve the problems with the actual runtimes on the Nagios box, but I think it's definitely a step forward in the right direction. So as I said, basic recommendations, these are all straight out of the book, nothing special. First is ditch WebRick. It's a pretty obvious one. If you haven't done that already, do it now. Set up your own web server. So Apache Passenger is a common deployment. We actually use Nginx Unicorn, but it's only because we have more experience with that. There's no real performance advantage that we found. Next is ditch SQLite. So by default, the stored configs actually go in the local SQLite database on your Puppet master. This doesn't really perform. It's only meant for development. Definitely put in some sort of dedicated database solution. Out of the box, this uses active record, so you've got a choice of MySQL or Postgres, whatever you happen to want to use. After you set that up, set it up on either dedicated hardware or work out what your performance requirements are, definitely. But then go and tune it. So out of the box, these databases come with pretty silly defaults. If you're running with those, it's definitely not the way to go. You might get some more performance than you would have whilst using SQLite, but it's not going to work for you in the long term. You can also implement a message queue. So the idea of this is that, say you've got many hosts reporting back and sending resources back to your centralized Puppet master. It's then going and trying to persist these to your database, say Postgres or MySQL. The problem is if these things are happening in parallel, or even one after the other really quickly, your MySQL server may not be able to keep up. They then added the functionality such that you could introduce a messaging queue, so Puppet could really quickly take the resource, persist it to the messaging queue, and then from there a job would actually come along and then say, okay, let's go and persist this to the database one at a time in sequence. The idea being there is you spread your load rather than having this thundering herd problem where lots of machines are trying to connect at once and do things. Turn thin Storeconfigs on. This is just a flick of a switch really. It just limits the amount of information that your host is sending back down to just the raw resources rather than a lot of extraneous information you don't need in a Storeconfigs database. And finally, we were still throwing ideas around in the office because we'd gone through all these recommendations and it still really wasn't doing anything for us. As I said, our bottleneck didn't seem to be on the actual Puppet master itself or the database machine. Purely it was the fact that we had to realize so many resources on our Nagios box. So someone said, all right, can we actually reduce the number of exported resources? So that's what we did. So as I explained, traditionally, Bob and Alice go and export lots of resources to say, hey, I've got all these services, they get persisted, Nagios comes along and picks up all those resources and then realizes them. We ended up with a solution that looked like this, whilst maintaining the same functionality. So now Bob and Alice only export one resource, it says monitor me. Seems pretty simple, but it doesn't really have all the information that the Nagios machine has to actually do everything, right? So the current solution, which I will explain, Alice only sends back and says, all right, I have services on me, therefore I have to be a monitored box. I'm a monitored machine. This is set to the Storeconfigs database. This means I have one monitoring resource per machine. Nagios then goes along and collects those, and then we set up monitoring in a crazy, crazy fashion for both Bob and Alice. So, only export one resource, which is this host monitored? To do this, we actually generate the Nagios configuration on the host itself, which may seem a bit crazy, but I will explain. So each one of our services uses a virtual resource instead of an exported resource. So MySQL, say you wanted to define MySQL, we have a virtual resource in there that then goes and defines some monitoring configuration. So that gets realized on the host. The host then goes along, the host comes along, collects the virtual resources itself, realizes them, sets up the monitoring configuration, and then dumps it in a local repository on the machine. Now, it's obviously not so useful. We then use the Nagios box and some certain setup to go and collect that configuration out of band. So what do I mean by out of band? We don't use the Storeconfigs database. We don't use the Puppet master at all. We don't use Puppet. We use Puppet to say that there's something available, but we then go and collect it ourselves. So this is what we started with. The add-on to this process is obviously I come along, use an out-of-band transport mechanism to go and get my config, and then Bob comes along and says, all right, here's the configuration back. Now for all the gory details. I say here be dragons. There's actually a nice section in the Cost is Explained manual, that if any one of you have seen that. This is actually the preface to a really complicated section on graph theory. So I preface now by saying that there's a lot of work ahead of us. So look, I'll start off first with what actually happens on the host. So I've got, I've got my MySQL module. Inside that, I define a class that says, all right, Nagios check. It's a virtual resource, just a basic Nagios type. It goes and sets up, goes and defines a Nagios monitoring configuration. I then have, that's all of it. So the top part is included in the MySQL module. When I go and actually use the MySQL module on my node, it'll include this class. The class will come along later and hoover up this configuration and then realize it. So what happens here, this is just a template for the configuration itself, just a basic set of check commands. We've actually got a lot more Nagios primitives, but we can just use the basic example here. And all it does is just a file resource, goes and dumps it in a particular directory on the host itself, so this out.d. That's what the Nagios machine will actually go along later and hoover up. You also include this in your node configuration, so it's just purely to say go along and collect all the services I happen to have set up. So obviously that Nagios object service could have been included in MySQL, Nginx, Postgres, whatever happens to be on the machine. I then go along on the host and say, all right, hoover up all the virtual resources and realize them. So what does this leave me with? I'm on the host, so I'm on Bob. Go and look in his out.d directory, and he's got a lot of service configuration set up for all these services. And just to have a quick look at one of those. If any of you are familiar with the Nagios monitoring spec, this is just a very basic config that says, hey, go and run this check MySQL command against host Bob. But that data is useless. Bob can't monitor himself, so the configuration doesn't really mean anything to him. He's just simply sitting there with a lot of configuration fragments on him that don't mean much. So how do we do it? The node needs to expose the data somehow. Now, I go into this and I will explain up front. This is only our particular implementation of collecting the configuration. You could use any particular mechanism you want. We wanted to use Puppet and NRPE because they're already in use. We know that they already exist on every machine, and so it makes sense to use the existing technology. You could go along just as easily and use a scheduled SCP or something to that effect. It doesn't really matter what you use. You just go along and collect it somehow. But look, we'll start off. We include this on the monitored host. So this is actually on Bob, just to say Nagios monitored. Now, this is probably going to be defined not on Bob itself, but in one of the actual, or on all of the actual service checks. So in my MySQL module, I might have included that Nagios type, which will then go and reference, this Nagios config host type. Now, the idea there being is that I can have, this exported resource that essentially simply says, I'm a monitored host, do stuff with me. Now, I can obviously export that many times. It's only going to be realized once, which is awesome. I then have a couple of basic file resources. The first is just to say, make sure that the out.d directory exists, so I need somewhere to dump my stuff. It's nothing complicated. The second one is actually a special check we've defined. So it says export Nagios config. So it's just an NRPE check that runs on the machine. And all it will do is just, when invoked on the machine, it will go in, spit out all the Nagios configuration to whatever happens to call it. And finally, I actually set up an NRPE command on the host, just to say, all right, someone can actually call this. Next, Nagios has to do something. So Nagios goes along, realizes the resource and says, okay, cool. Bob is a monitored host. I need to go and collect configuration from Bob. Genfile is actually a custom type we've written, but it doesn't really do anything complicated. All it does is runs a command on the Nagios host to then go and say, all right, go and call Bob, call Alice, pick up all their config. It could really be, as I said, any transport mechanism. Genfile in itself is nothing particularly complicated. It very, very simply just invokes a particular collect Nagios config command, which just goes back to Bob and runs that export virtual resources check, and then says, okay, spit everything back at me. And finally, the node itself needs to expose the data somehow. So this is just the setup of the Nagios host again, just to say, all right, go along, hoover up all the monitored hosts, as well as realize any other check definitions I need to know. So I need to know what check MySQL looks like before I can go and call it. But really, the basic thing is really such that Bob only simply says, all right, I have MySQL on me. Here's the configuration to monitor Bob's MySQL service. So just say run check MySQL against Bob. Now it just goes along, picks up all those configs, dumps it into its own configuration directory. We do run some validation before we go and notify Nagios, but at its core, all we've done is gone, picked up the config, stuck it into Nagios, and said Bob's your uncle. Probably a bad expression. So look, that goes back to the picture of what we're really doing. So Bob exports a resource that says, I'm a monitored host. Nagios server will eventually come along and pick that up. It will then go and run its NRPE check against Bob to say, okay, give me all of your monitoring config, and Bob will spit it back out, and the Nagios machine will actually dump it into the Nagios configuration. And look, that's really the crux of it. I did also want to say that we're hiring sysadmins. I'm sure many people are. We're looking for remote workers. So we're a Sydney-based company in Australia. But anyone that wants to come and talk to us, we'll actually fly out all new hires and give them a holiday for a month in Sydney. And yeah, questions and complaints. I realise it's a very bastardised solution, but the idea at its crux was to try and reduce the number of resources we were dealing with.